Hey, how's it going? Welcome back to the channel. It's Jyotinder and I do LeetCode questions here on YouTube. So if you're into that kind of stuff, be sure to check out my channel and subscribe to it if you'd like to see some more content. Yeah, so today we'll be looking at this problem that is called spiral matrix. It's a medium level problem. It's pretty interesting to solve. So let's see what this problem is about. So we're given that you are given a matrix of m cross n elements and you have to return all the elements of the matrix in a spiral order. So all you need to do is you're given a matrix and you need to traverse it in a spiral fashion and return that traversal ordering back to the caller in the form of a matrix. So the example that they've given us is this 3 cross 3 matrix with elements which are 1, 2, 3, 4, 5, 6, 7, 8, 9. And you need to traverse this in a spiral manner. So that would mean you first of all start at the top row, you go from the left to the right, you write 1, 2, 3. Then you start going downwards from the last element of the top row and you get 6, 9. Then you start moving towards the left and you get 8, 7. You start moving towards the top, you get 4. And finally, you move towards the right again and get 5, right? So it's like you're moving inside, throughout the matrix in a layer-wise fashion. You first traverse the outermost layer, then you start moving towards the inner layer and so on and so forth. So this was a square matrix. They haven't guaranteed us that we'll get a square matrix. And it can be a rectangular matrix as well, as the example number 2 shows. So this example number 2 tells us that we have been given a 4 cross 3 matrix and the traversal will be pretty much the same. You'll traverse the topmost row from the left to the right, and then you'll start moving towards the bottom once you reach the last column. Then you'll start traversing towards the left once you reach the bottommost row, and then you'll start moving towards the top and you'll encounter 5. And once you've traversed this outer shell, you start moving inwards and you cover the elements that are inside it, which are 6 and 7. And you return this ordering in the form of a vector or an array, whatever, right? So how will we approach this problem? It seems a bit tricky at first because it's not a traversal that we've usually done. So the approach that we'll be using here is we'll be defining boundaries. We'll be defining a left boundary, a right boundary, a top boundary, and a bottom boundary, right? So what those boundaries will do is, let's say we want to move from the left to the right. The left boundary will define where we start and the right boundary will define where we stop, right? So we'll say we'll start off at the left boundary. In the topmost row, we'll start off at the left boundary and start moving towards the right. And once we've reached the rightmost boundary point, we'll stop. And once we're at the rightmost boundary, we'll start at the top and move towards the bottom. And then we'll start at the top and move towards the bottom in the rightmost column, the right boundary, right? And then we'll start moving downwards. Similarly, once we reach the bottommost point, once we reach the bottommost boundary, we'll start at the right boundary, which will be 9, and then start moving towards the left-hand side, towards the left boundary, and so on and so forth, right? So I think it'll be a little bit more clearer once we start coding it out. So let's get right into it. All right, so the first thing that we'll do is define a vector to store our result. So we'll just write vector int, and I'll call this res. Now we'll just check a boundary condition. If the matrix size is 0, if that is the case, that means we have no elements in the matrix, and we'll return back an empty resulting array. Now, we need to define all the boundaries, right? For our traversal, we need to define a left boundary, we need to define a right boundary, we need to define a top boundary, and we need to define a bottom boundary, right? So we'll start off at the left boundary, move towards the right boundary in the top row. Then we'll start off at the top row and move towards the bottom boundary while traversing the rightmost column. Similarly, after that, we'll start traversing the bottommost row from the right boundary towards the left boundary, and so on and so forth. We'll start continuing off in the traversals. So the boundaries will be defined as, we'll write int top equal to 0 because we'll start off at the 0th row. We'll define the bottom boundary as rows minus 1 because the number of rows minus 1 will be the last possible index for a row, right? So that will be the bottommost row. So we'll just write matrix dot size minus 1. So this will be the number of rows minus 1. After that, we'll have the left boundary. The left boundary will obviously be 0 because the leftmost column is the 0th column. So we'll write left equal to 0. Now we have the rightmost boundary. which will be the number of columns minus 1. Again, minus 1 because we are using zero-based indexing. So we'll write right equal to number of columns, which will be matrix 0.size minus 1, right? So once we've done that, we can start our traversal. So the traversal will go on while left is smaller than equal to right and while top is smaller than equal to bottom. So this is the breaking condition. Once this condition gets violated, we'll exit out of the loop. Okay, so now that we've done this, what we need to do is start traversing towards the right in the topmost row. So first of all, we'll traverse towards the right from in the topmost row, right? So I'll just add a comment here. I'll just write traverse right so that it's clear what we're trying to do. We'll run a for loop for int I, for int j, let's say, equal to left. For int j equal to left, because we'll start off at the left boundary. While j is smaller than equal to right, because we'll move on until we hit the right boundary. So plus plus j. And all that we need to do is simply push this result back into the resulting vector. So we'll just write res.pushback matrix. The current row will be defined by the topmost boundary because we are traversing through the top boundary, right? The topmost row. So matrix top, because this will define the row that we're traversing, and the column will be defined by the variable j that we are using in the for loop. Yeah. So once you traverse through the topmost boundary, right, to the first row, through the topmost boundary, we need to update the top pointer. We need to update the top boundary because we'll never be coming back to this first row, right? Because we've already traversed it and we don't want repetition. So we'll never be coming back to this. So we need to update the top pointer, right? That we have finished iterating through the top boundary, and we need to update the top pointer so that we can continue off in the further traversal. So we'll just write top plus plus. Now we'll start traversing towards the bottom. So we'll just write traverse bottom. Now we'll write a for loop for int I equal to, now we'll start off at the topmost row, right? Because we're traversing the rows from the top to the bottom, and we'll start at the topmost row. And you must notice that we've already updated the top. So this time, instead of starting off at row 0, we'll start off at row 1, right? So this will automatically prevent any duplicates from occurring. So I'll start off at the top row. While I is smaller than equal to bottom plus plus I, all we need to do is just simply push back the current element into the resulting vector. So we'll write res.pushback matrix. The current row will be defined by the variable I, and the current column will be defined by the right boundary, because right now we're traversing through the rightmost boundary, right? So we'll just write right here and we'll add a semicolon. Now, once we've traversed through the rightmost boundary, we'll never be coming back to any of these elements. We've traversed the rightmost boundary, we've traversed the rightmost column, and we never want to come back to it. So we'll update the right boundary. So we'll write right minus minus to move the right boundary towards one step towards the left. So I'll just write right minus minus. Now we need to traverse the bottommost row from the right to the left. So I'll just write traverse left, right? So let's open a for loop for int j equal to right. So this will start at the right boundary, the updated right boundary, because we already updated it. So this will start at index 1. So we'll start off at the right boundary while j is greater than equal to the left boundary and minus minus j. Once we've done that, just push this back into the result. So res.pushback matrix. The current row will be defined by the bottom pointer. So we'll just write bottom. And the current column will be defined by the variable j. So I'll write bottom slash j, right? Now once we've done that, we have traversed through the bottommost row. And again, as always, we'll never be coming back to this row because we don't want any duplicates. So we'll update the bottom pointer as well. So we'll move the bottom pointer one step up. So we'll just write bottom minus minus. Now, the last thing that we need to do is simply traverse back up in this outer shell. So we'll just write for int I equal to bottom. Note that this is the updated bottom, so this will start at index 1 instead of index 2. So I equal to bottom, while I is greater than equal to top. So while we're doing that, we need to update it by writing minus minus I, because we'll be moving upwards. Right, so once we've done that, We just need to push this back as always. So we'll just write res.pushback. We'll push in this matrix element. So we'll just write matrix. The current row will be defined by the variable I, and the current column will be defined by the left boundary. So we'll just write left here. And once we've traversed the leftmost column, we need to update the left boundary as we did earlier with the rest of the boundary. So we'll just write left plus plus, right? And that is our traversal, and that is it. And we can start returning the answer. So we'll just write return res, right? But there is one small mistake or one small bug that you'll find in this code. Because if I run this code, you'll see that we'll probably face some repetition. You'll see that some elements start to get repeated. And that is because this breaking condition of left being smaller than right and top being smaller than bottom only gets checked once you have traversed through each of these for loops, right? Once you've traversed through each of these for loops, that is when the boundary condition gets checked. And it's possible that you might have finished traversing through the array, but you'll notice that you still haven't encountered this breaking condition, right? You might have finished traversing through the actual matrix, but you still haven't faced this boundary condition, because this will only come when you have traversed through the last for loop as well. And that has a possibility that while you're traversing through this last for loop, you might overshoot your boundaries and start pushing in duplicate elements because you still haven't checked this boundary condition. So we need to check some condition to make sure we aren't overshooting any element in each iteration of every for loop, right? So how will we do that? This sounds a little bit confusing, but it's really easy. All you need to do is make sure your for loop only runs when your resultant array has not yet reached the size of the actual matrix. So while the number of elements in the resulting vector is not equal to the actual number of elements in the matrix, you'll run those for loops. So we'll check that condition as well. So we need to define another variable. Let's call that total. So I'll call int total. This will be equal to the number of elements in the matrix. So I'll just write matrix dot size multiplied by matrix 0 dot size. So this will be the total number of elements that are there in the matrix, and we need to check that in every for loop, right? So we've defined this as total, and I'll just write another condition in each of these for loops, another breaking condition, that while res.size is smaller than total, while the size of the resultant vector, while it is smaller than the total size, until that point we can keep iterating through each of these for loops. And we'll need this in every for loop, so I'll just copy this up and I'll just paste it in each of these for loops like so. And like so. Now let's submit this, and this should run. And does give us a correct answer, so I'll submit this. And we get a runtime of 0 milliseconds, right? So that is how you solve this problem. If you enjoyed this video, be sure to hit the thumbs up button, subscribe to the channel if you want more content, and leave your comments down below, and the code as always will be present in the description. Yeah.